Hello friends, this video on Application of Trigonometry Part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Part 1 and Part 2. Let's take one more example. 1.5 meter tall boy is standing at some distance from a 30 meter tall building. So this guy is 1.5 meter tall, standing from a 30 meter tall building. This height of the building is 30 meter. The angle of elevation from his eyes to the top of the building increased from 30 degree to 60 degree as he walks towards the building. That means if now the angle of elevation is 30 degree, the moment he comes somewhere here, the angle of elevation becomes 60 degree. We have to find the distance he walked. That is, let's see this animation now. So this angle of elevation from this guy to the top of the building is 30 degree now. Let's suppose this is 30 degree. Now he walks from here to this point, and now the angle of elevation is 60 degree. We have to find the distance traveled. This distance we have to find. Correct? So let's draw a triangle on this. Let's draw this line, this line, this line. So we have got this triangle now. Correct? Now this height was 1.5 meter. The total height of the building is 30 meter. Correct? The total height from here to actually this point, you add this point. This was a 1.5 actually. Total height of the building is 30 meter, so this height will become 30 minus 1.5, that is 28.5. So this black line is 28.5. Why? Because 28.5 from here to this point, give this name of the point ABCD. So AB, and this is, let's suppose, E. So A, the whole thing is A is 30 meter. BE is equal to the height of the guy, that is 1.5. So AB will be 28.5 because we are looking for this triangle AB, D and ABC. Correct? So this height is 28.5. We have to find the distance he walked. So what we can do now is, in this triangle ABC, using this tan theta, we have this height. We can get this distance CB. Also in triangle ABD, we can get this distance BD because we have this angle, we know this value. If we know BD and BC, we can find a difference, that is BD minus BC. Correct. So what we can do, let me put this. This is D1, let's suppose distance 1, BC, and this is distance 2. Just for the clear observations. Correct. Now in triangle ABC, the right triangle, since C is the reference, frame of reference, this will be the hypotenuse, this will be perpendicular, and this guy will be base. Correct. I have to derive a relation between perpendicular and base. So let's use the formula Pandit Badri Prasad, Hare Hare Bol. So if I have to find the relation between perpendicular and base, I'll use tan theta, sin cos tan. Correct. So I'll use tan theta. So in triangle, I'll say in triangle ABC, the smaller triangle, I'll say tan 60 degree is equal to P by B. That is nothing but AB by BC, and that is nothing but 28.5 by D1, and this is nothing but, or tan 60 is nothing but root 3. Root 3 is equal to 28.5 by D1. From this we get D1 is equal to 28.5 by root 3. This is what we have got in equation number 1. So we have got D1. Now we have to find D2. So we will take triangle ABD. Now we see in triangle ABD, if you see, Again, since D is the frame of reference, hypotenuse is this side, AD, perpendicular is same, and base is the bigger one, the whole big side, BD. So again, you have to find relation between perpendicular and base. So we'll use again tan theta. So we'll say tan 30 degree is equal to, again here P by V. In this case, perpendicular is again 28.5, but base here is D2 in triangle ABD, and tan 30 is nothing but 1 by root 3 is equal to 28.5 by D2, or we get D2 is equal to 28.5 root 3. Correct? This I can rationalize also. So total distance travel is nothing but, as a dt traveled, distance traveled is nothing but d2 minus d1, because this is the distance we are looking for, right? This is x, d2 minus d1, and that is nothing but 28.5 root 3 minus 28.5 by root 3. So let's rationalize this guy at least, because we'll get root 3 in both case. So this becomes 28.5 root 3 minus this becomes 3, and this is 28.5. If you cancel this becomes 9.5. So 28.5 minus 9.5 root 3, and this is nothing but 19 root 3, and the unit will be meter, because everything is in meter. So 19 root 3 meter is the distance traveled by the car. Correct? So this is the distance. What we have done, we have just observed this problem carefully. The person moved from here to here. The height of the person was 1.5, the building was 30. So we subtracted this to get height of AB. We formed this triangle ABC and ABD, where angle D is 30 and angle C is 60 degree. We had this AB also. Then geometrically we were supposed to find DC. So we found D2, we found D1, we subtracted to get DC. The main challenge was to get this triangle done. Let's take one example. From a point on the ground, the angle of elevation of the bottom and the top of the transmission tower fixed at the top of the building, 20 meter high building, are 45 and 60 degree. We have to find the height of the top. So let's try to solve this question. This is the building. On this building we have this tower, correct? And there is a point on the ground. Also, the question says the angle of, from the point on the ground we have delivered, angle of elevation on the bottom and the top of the transmission tower. So we'll take this angle of elevation on the bottom, that is 45 degree. This guy is 45, and the top of the tower from the same point is 60 degree. So this angle is 60 degree. We have to find the height of the tower. So let this be x. Let's draw a triangle on this. So let's join this point, line this point. This becomes a triangle. Let me name the triangle. Triangle A, B, C, D. Let this be the triangle. We have to find AD, that is height of the tower. And we are told that the height of the building is 20 meter. So DB is 20, that is told to us. Correct? So what we can do? See, since this is known, this angle is known, we can find BC in this triangle BDC. Correct? Now then, in the bigger triangle, since BC will be known, there is a common side between the bigger triangle and smaller triangle. Since the BC will be known, we can find the AB height. Once we'll have AB, we know DB, we can subtract to get x. What we are doing is, we have two triangles, we have common side BC. Let's find the common side first. So if you see, if you take 45 degree as the frame of reference, this side is hypotenuse, this is perpendicular, and this is base, right? And the common side is B only, base one. So we are looking for something which has P and B both. So we'll use the formula Pandit Badri Prasad, Hare Hare Bol. So P and B is in tan 1. So we'll say in triangle, small triangle, that is DBC, tan 45 degree is nothing but P by B, and P is nothing but DB, that is 20, and B is nothing but CB. And tan 45 is equal to, or I'll say tan 45 is 1 is equal to 20 by CB, or I get CB is equal to 20. So this guy is 20, it is known to me now. Correct. Now we'll take a bigger triangle. We'll take bigger triangle, triangle ABC. This side is known, I want to find this height. Now in this bigger triangle also, since the angle of reference is angle C, is 60 degree, this side AC is height. I put on this, the base is same and the perpendicular is the bigger one, AB. So here also we say tan 60 degree is equal to perpendicular base. Here perpendicular is AB and base is again CB only. So AB is nothing but x plus 20, correct, the whole height, and CB is nothing but 20, just now we found. Or we can say tan 60 is nothing but root 3, tan 60 is nothing but root 3, and this is equal to x plus 20 by 20. So we'll solve this. X is nothing but 20 root 3 minus 20, or 20 into root 3 minus 1, and the unit is meter. So this is meter, and that is my answer. So the height of the tower is 20 root 3 minus 1. Very simple, just try to understand the problem, draw the diagram in this fashion, the right triangle, and then you'll get the answer. Correct? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.